So welcome to this session on numerical integration. We will continue with Simpson's 1/3 rule, 3/8 rule and Weddle's rule, and we'll start with problem solving. Use Simpson's 1/3 rule to evaluate integral 2 to 8 dx by log x to the base 10. Use 7 ordinates. So we are using 7 ordinates, so h equal to 8 minus 2 by 6. The number of intervals will be 6. So points will be 2, 3, 4, 5, 6, 7, 8. And y equal to 1 by log x to the base 10. So y0 will be 1 by log 2 to the base 10, that is 3.3219. You can use the calculator. Similarly, y1 is 1 by log 3 to the base 10, which is 2.0959. Likewise, you can calculate y2, y3, y4, y5, y6. And by Simpson's 1/3 rule, the formula goes something like this. Integral a to b y dx is h by 3 y0 plus yn plus 4 times y1 plus y3 plus yn minus 1, the even numbers, plus 2 times y2 plus y4 plus yn minus 2. We take the even coordinates. So this becomes h by 3 y0 plus y6 plus 4 times y1 plus y3 plus y5. In this context, you have up to y6 plus 2 times y2 plus y4. Substituting, you get 9.7203. So next problem is on Simpson's 3/8 rule. Use Simpson's 3/8 rule to evaluate integral 0 to 0.3 1 minus 8x cubed raised to half dx by considering 3 equal intervals. So h equal to 0.3 minus 0 by 3, which is 0.1. So your points will be 1, 0.1, 0.2 and 0.3, because h is b minus a by n. N is 3 here. Y equal to 1 minus 8x cubed raised to half. Y0 will be, when you put x as 1, you get 1. Y1 will be 1 minus 8 into 0.1 cubed raised to 1 by 3, which is 0.9973. Continuing like this, we can calculate y2 and y3. And Simpson's 3/8 rule says that I equal to 3h by 8, y0 plus yn, the first and last, plus 3 times y1 plus y2 plus y4 plus y5 up to yn minus 1. We take all the values except multiples of 3, plus 2 times y3 plus y6 up to yn minus 3. Then we take the multiples of 3. So this is 3h by 8, y0 plus y6, y0 plus y3 here, plus 3 times y1 plus y2, because we only have up to 3, so this term won't be there. So substituting the values, you get 0.2916. The next question goes something like this. Use Weddle's rule to compute the area bounded by the curve y equal to fx, the x-axis and the ordinates from the following table. So you have 0, 1, 2, 3 up to 6, and we calculate y, and you're given the values here. So this is y0 is 0, y1 is 2, y2 is 2.5, y3 is 2.3 and so on. y6 is 1.5 and h is b minus a by n, 6 minus 0 by 6, which is 1. Now by Weddle's rule, I will be 3h by 10, y0 plus 5 y1 plus y2 plus 6 y3 plus y4 plus 5 y5 plus y6. So we go like 1, 5, 1, then 6, 1, 5 and so on. So substituting the values, you get 11.49 square units. Coming to one application of this, find the distance traveled by a train from 8:20 p.m. to 9 p.m. from the following data. So you're given the time and the speed. So there are 5 values and n equal to 4 here. So time interval will be 10 minutes. That is 1 by 6 hours. So h is 1 by 6. So we use Simpson's 1/3 rule. So distance will be integral t1 to t5 v dt. Because we are given the speed, you get the distance by integrating the speed. So you are given v0 as 24.2, v1 as 35, v2 as 41.3, v3 and v4. And using Simpson's 1/3 rule, because n has to be a multiple of 2, I equal to h by 3 y0 plus yn plus 4 times y1 plus y3 plus yn minus 1, the odd numbers, plus 2 times y2 plus y4 up to yn minus 2. So substituting the values, you get y0 is 24.2, yn is 39.4, plus 4 times 35 plus 42.8, plus 2 times the third value, which is 41.3. So your answer is 25.4. So we have seen how to use all the three rules, Simpson's 1/3 rule, Simpson's 3/8 rule, and Weddell's rule in problem solving. Thank you.